Hi everyone, for today's lesson we are going to learn how to simplify radical expressions. Some of you may remember what we are about to learn from Algebra 1, but this is a review of what you have learned in the past. Our learning targets for today is for you to be able to say, I can simplify radical expressions and rewrite expressions in what we call simplified radical form. So a lot of directions are going to use the language of simplified radical form. You will also see at the very top, I have a radical symbol for you, also known as a square root symbol for our class. Before we get started, please make sure you have the following materials. You will need scissors, a glue stick, something to write with. You will need some color highlighters. And you will need to have printed out the Unit 1, Day 9 interactive notebook cutouts. We will start with the perfect squares list to study, then simplified radical form, then multiplying radicals and raising a radicals to a power, and finally dividing radicals. So that is the order in which we are going to be working with our cutouts today. Please feel free to pause the video to grab all of the supplies that you will need in order for you to complete this lesson. So the first thing that I want to do is I want to talk about what a radical expression is. A radical expression looks like this. We have a square root symbol. And in this square root symbol, we will have like a number on the outside. The number on the outside is known as the coefficient. C-O-E, so this is supposed to be an E, C-O-E-F-F-I-C-I-E-N-T, the coefficient of our expression. Underneath this square root symbol is called the radicand. The radicand is whatever is underneath the square root. So you'll have the coefficient in front, then the radicand, and this is called the radical symbol. So I will highlight this and say that this is called the radical symbol, also known as a square root. So for example, if we were to talk about 2 times the square root of 7, 2 would be considered the coefficient. And 7 would be called the radicand. And that's because 7 is underneath the square root symbol. So you might see these vocab words as we are going through these problems. It might say simplify the radicand or multiply the coefficients. I need you to be aware of what those words mean and how to use them. Okay. I also want to express that this reads that this is 2 times the square root of 7. So we read this 2 times the square root of 7. That's how you read this. 2 times the square root of 7. So sometimes it's shortened into 2 root 7. Be careful. remember that this is multiplication 2 times the square root of 7. So one of the things that you will need to know, because we're working with square roots, is you will need to know a lot of perfect squares. So here is our perfect square list that I need you to be familiar with, be able to recognize, and know how to use them. So we are simply going to glue. If you have tape, you're welcome just to use tape. But we are just going to glue this piece of paper directly into our notebook. And what this is it's a perfect squares list that I need you to be aware of. Looks like I missed a root right here. So 1 is considered a perfect square. The square root of 1 is 1. The square root of 4 is 2. What square root means is what times itself 2 times equals that number. 1 times 1 is 1. 2 times 2 is 4. The next one is 3. Square root of 9 is 3. 3 times 3 is 9. The square root of 16 is 4, and that's because 4 times 4 equals 16. The square root of 25 is 5. 5 times 5 is 25. The square root of 36 is 6. 6 times 6 is 36. The square root of 49 is 7. 7 times 7 is 49. The square root of 64 is 8. 8 times 8 is 64. The square root of 81 is 9. 9 times 9 is 81. The square root of 100 is 10. 10 times 10 is 100. Continuing with that pattern, the square root of 121 is 11. The square root of 144 is 12. The square root of 169 is 13. The square root of 196 is 14. The square root of 225 is 15. The square root of 256 is 16. The square root of 289 is 17. The square root of 324 is 18. The square root of 361 is 19. The square root of 400 is 20. These are our perfect square numbers going from 1 all the way to 20. These are the ones that I need you guys to study because they will appear over and over and over again in our problems that we will be working with. Some additional common perfect squares that you will see is the square root of 625, which is 25, and the square root of 900, which is 30. These are ones that generally appear a little bit more often outside of the 1 through 20. Please, please, please make sure that you study and know how to work with these values because we will be working with them as we enter simplified radical form. So the numbers that I need you to be familiar with are the ones that are underneath the square root. All right, here we go. Please go ahead and take out the simplified radical form. So we're going to go ahead and paste it just below. And directions will say, please simplify the radical into simplified radical form. So what does simplified radical form mean? It means to have it be fully simplified. There are no perfect square factors other than 1 under the square root. So that means that you have to look at the number that's underneath and ask yourself, can any of these numbers be a factor of? Factor means multiply together to equal these numbers. But there are no perfect factors other than 1 underneath. And there are no radicals in the denominator. So eventually we will be working with fractions. And we want no radicals in the denominator and no perfect square factors other than 1 after you've simplified. Let's look at our first example. We want to simplify the square root of 25. So what we want to do is we want to look for, does there exist a perfect square number that can go into 50? Well, 25. I know that 50 can be rewritten as the square root of 25 times 2. 25 times 2 is 50. I can split apart that square root into the square root of 25 times the square root of 2. I know that the square root of 25 is equal to 5. So I'm going to replace this expression with 5. The square root of 2, I can't make anything up here work, so we leave it as 5 times the square root of 2. This is considered fully simplified. I have no perfect square factors can go into 2, so I leave it just like that. Let's look at 200. Well, looking at all of our numbers, I could probably work with 25, but is there a bigger number that can go into 200? Always look for the largest. How about 100? I know that this is 100 times 2. So I can split apart my multiplication to make this the square root of 100 times the square root of 2. The square root of 100, I know that the square root of 100 is 10. So therefore, I'm going to rewrite this as 10 times the square root of 2. All right, I'm going to do example number 2 one more time down here, but this is another way. What if you didn't recognize that 100 worked? This is called another way. What if instead you saw that 25 worked? Instead, you saw this as 25 times 8. And you said that this is equal to the square root of 25 times the square root of 8. Well, yes, this is the square root of 25 is 5 times the square root of 8, but 8 has a perfect square factor that's remaining, so you have to keep going. So we keep going. So I'm going to write this up here. And I have 5 times the square root of 8. And I know 8 is 4 times 2. So I'm going to rewrite this as 5 times the square root of 4 times 2. So that is 5 times the square root of 4 times the square root of 2. The square root of 4, so this is 5 times, this piece becomes 2 times the square root of 2. And 5 times 2 is 10 square roots of 2. I still end up with the exact same answer. But do you see how much more work that is to keep going? It's a lot easier just to find the biggest perfect square factor from the start. If you don't, it's okay. You just have to keep going and you can still end up with the right answer. All right, let's go ahead and I have to flip my page. Let's talk about multiplying radicals and raising a radical to a power. So please go ahead and take out multiplying radicals and raising a radical to a power. And we are going to paste this directly into our notebook. I'm going to draw a line just so that I can have some separation as I do some my examples. Okay. First thing we're going to do is we're going to start off with multiplying radicals. So whenever you're multiplying radicals, the first thing that you want to do is you want to multiply the coefficients. Now remember that coefficients, that represents the number in front of your radical. So that is always our step one. So I'm going to do an example as I'm explaining multiplying. So my example is going to be 3 times the square root of 5 times 2 times the square root of 10. So step one is to multiply the coefficients. So my coefficients in this case are 3 and 2. And I'm going to multiply 3 times 2. Excuse me. 3 times 2 equals 6. The next thing I'm going to do is I'm going to multiply, no, this is not multiple, it's supposed to be multiply the radicands. So multiplying the radicands. That is the number under the square root. So in this case, that's 5 and 10. I'm going to multiply 5 times 10. And that is 5 times 10 is 50. Step number 3 is I need to simplify the radical completely. So just like we did in our last example, I need to keep going when it comes to the square root of 50. I know that 50 is really 25 times 2. So we always want to look for the biggest perfect square. I'm going to make a note of that. Always look for the biggest perfect square factor. So we want the biggest. That's really, really important because the larger it is, the less steps we will have later on. So this is 6 times the square root, and a shortcut is just to know that the square root of 25 is 5. That's a shortcut. Times the square root of 2. 6 times 5 is 30, so my answer is 30 square roots of 2. And that's how you multiply radicals. Let's go ahead and talk about raising radicals to a power. So a power is another word for having exponents. Raising to an exponent. So that's like a square or a cubed or something like that. That's what power means, is an exponent. Step 1, so I'm going to do an example and go through the steps as I go. So here's my example. We have, and I have 2 approaches for this, so I'll show you both ways. We have 2 times the square root of 7 squared. So step 1 is to square the coefficient. Square the coefficient. Remember that coefficient represents the number in front. So I'm going to square the coefficient. So this becomes 2 squared. Then I'm going to square the square root. So distribute the square to the square root. So each piece gets squared. 2 squared is 4. And what's really cool is that the square and a square root eliminate each other, leaving you with just the number 7. Note that the square root symbol goes away and becomes a parentheses. So we're just going to turn it into a parentheses. 4 times 7 is 28. That's one way you could view this problem. Another way that you can view this problem is you can say that 2 times the square root of 7 squared means 2 times the square root of 7 times itself twice. So you would multiply, just like over here, you would multiply your coefficients. So that would be 2 times 2, which is 4. And you would multiply your radicands to make this the square root of 7 times 7, which is 49. So this is 4 times the square root of 49 is 7, and that is still going to be 28. Both ways will get you the answer of 28. So step 3 is to distribute or multiply the coefficient and the parenthesis, which is how we were able to get our 28. So whenever you're raising to a power, I would just recommend distributing the square, but it just depends on what works for you. You would square the coefficient, square the square root. The square root symbol goes away and becomes a parentheses, and then you would distribute or multiply the coefficient and the parentheses, and that's what we did to get the answer of 28. So far we've talked about simplifying, multiplying radicals, raising radicals to a power, and now we're going to talk about dividing radicals. So let's go ahead and glue this into our notebook. So here is dividing radicals. When it comes to dividing radicals, you always want to look for, so this is step number 1, you want to look for a relationship between the radical in the numerator, which remember numerator means the top of the fraction, and the radical that's in the denominator. So you're going to say an expression where there's going to be a radical in the numerator and a radical in the denominator, and you want to look for a relationship. Can you simplify this relationship? Yes or no? In this problem, there is a relationship. So we're not looking at 3. I'm just looking at 2 and 6. Whoa, let's clear that up. There we go. Okay. 2 and 6. I know that 6 and 2 are related. I can rewrite this as 3 times the square root of 6 divided by 2. I can just turn this into one radical. 6 divided by 2 is 3. So the answer is 3 times the square root of 3. That is it. That is all. And this works if there is a relationship between the radical, or the number under the radical in the numerator, and the radical in the denominator. So I'm going to remind you guys that in fractions, the top is called the numerator, and the bottom is called the denominator. You probably already knew that in fractions, but this was just a friendly reminder. Just so that you remember where everything goes. Numerator is on top, denominator is on the bottom. So that is one way. Another way, so I notice I wrote the words if possible, because a lot of times this is not possible. So if it is possible to simplify this relationship, do so. So that's always step 1. But then, if there is still a radical in the denominator, so I'm looking at my relationship right here and I see that there's no radical in the numerator and no relationship. If there is still a radical in the denominator after completing step 1, then you will multiply both the numerator, which means the top of our fraction, and the denominator by the radical that's in the denominator. So the radical in the denominator. You're going to multiply by the radical in the denominator. Then we'll simplify. This process is called rationalizing the denominator. We will be working, you will see, rationalize the denominator is a phrase that you will see a lot. Okay, so the way I always think of this problem is I always think of like getting a flu shot. When you have a flu shot, what is in the flu shot? A little bit of the flu. In this problem, we have a disease, we have a problem, and we have a root in our bottom. Nobody wants a root in their bottom. Nobody wants a square root. That is bad. So the way to get rid of it is to multiply both the numerator and the denominator by the square root of 5. Now watch what happens. When we multiply straight across, this becomes 3 square roots of 5 all over the square root of 25. Let's keep going with simplifying. We have 3 times the square root of 5, and we know that the square root of 25 is 5. Stop here. This is our answer. I want you guys to please be careful. The square root of 5 and the number 5 are two different numbers. Do not cancel the 5s. So the 5s do not cancel. They cannot cancel because they are completely different numbers. We know that the number 5 is the number 5. But what is the square root of 5? 2.36067,977. Not 5. So because it is not the number 5, you cannot cancel these values. Not cancel. The 5s cannot cancel. And that is the end of today's lesson. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.